Assalamualaikum and good morning, everyone. All right, today we continue our online class series, Revision Physics Form 4. Today we continue on Chapter 4, Heat. Okay, so before that, let's refresh what we have discussed in Chapter 4, Heat, some important points. Okay. The first part in this topic, we have discussed about concept of thermal equilibrium. Okay, and then you also introduced the word thermal contact. The word thermal actually refers to heat. Okay, thermal contact means not necessarily the object must be in contact. Once there is heat transfer, so we call it thermal contact. For example, you are sitting close to the fire, you can feel the heat transfer to you. That one also is thermal contact. Okay, bukan semestinya nak ada contact nak ada sentuhan. Okay, that's why we call it heat contact ataupun thermal contact. Okay, concept of thermal equilibrium. Let's say there are two objects. We have object A and object B. Let's say A is hot, B is cold. Okay, once the two objects in thermal contact, heat will be transferred between the two objects. Heat will be transferred to B from A, higher rate, and at the same time, there is heat transfer between B to A at slower rate. Okay, cold to hot also ada tapi slower rate. Okay, so after sometimes means a few minutes after that, or maybe a few 1 hour after that, depends lah. Okay, so after sometimes the heat transfer between two objects become equal. Dia jadi sama. Okay, something like this. Maybe after 5 minutes. Okay. Okay. Same rate. Okay. So when same rate, we can say rate of equal. When you calculate for net rate of heat transfer, zero. Do you understand what does this mean? Net, okay, let's say from A to B is 100 joule per second. Okay, B to A also is 100. If you calculate net, meaning 100 minus 100, that is 0. So we call it net rate of heat transfer 0. What happens to the two objects? Temperature become equal. So when this happens, we call it thermal equilibrium. So thermal equilibrium is achieved. Okay. So one application that apply thermal equilibrium is thermometer. Kita apply concept of thermal equilibrium. That's why when you use thermometer, you put under your tongue or under your armpit, you need to wait for 1 minute. Okay, because after that 1 minute, the thermometer reading is equals to temperature of patient body or your body. Yeah, that's the reason. Okay, so now the formula to calculate. So let's say there is a formula to calculate temperature theta of unknown liquid. So L theta, L theta, okay, is length of L theta. This is length L100. This is L theta. Okay, so to find what is theta, just use the formula L theta divide 100 multiply 100 degree. Okay, and then part 2 we discuss about specific heat capacity. Muatan haba tentu C. Okay, smaller C heats up the goes down also. So dia punya specific heat capacity smaller, heats up faster, goes down faster. Also vice versa lah. Kalau C besar, dia heats up slower, goes down also slower. Lambat panas, lambat sejuk. Okay, itu untuk specific heat capacity. Okay, specific heat capacity, you kena memorize the formula. Q equals to MC theta. Capacity U divided by M theta. So you can see the relationship between C and theta inversely proportional. Means larger C, smaller change in temperature. Okay, maksudnya dia heats up slower. Okay, heats up slower. Okay, and then we discuss about latent heat. Okay, betul ada dua ni. Fusion and vaporization. So the part was simple. Fusion ialah untuk melting, peleburan ataupun freezing. Ini dua proses kita panggil fusion. Vaporization ialah proses boiling ataupun condensation. Evaporation pun boleh. Maksudnya change liquid change to gas or gas change to liquid. Okay, so itu beza je. Formula Q equals to ml. So is latent heat equals to Q divided by M. Okay. So untuk fusion, kita ada specific latent heat of fusion, specific latent heat of vaporization. So just differentiate between that two. So for this latent heat, no change in temperature. There is change in phase. Okay. Okay. Untuk specific heat capacity tadi, ini change in temperature. Kita baliklah. Ada change in temperature. No change in phase. Maksudnya keadaan dia tak berubah, physical state tak berubah. Kalau solid, solid, liquid, liquid. Itu specific heat capacity. Hanya temperature je bertambah atau berkurang. Kalau latent heat ini, dia ada change in phase, like solid become liquid, liquid become gas. Okay, temperature constant. Okay, itu beza. Sebab formula tak sama, so you kena pastikan you faham ni. Okay, and then we discuss about gas law. Okay, gas law, kita ada this triangle. Sorry. Okay, this triangle PVT. So for gas law, just discuss about properties of like pressure, volume, and temperature. Okay, study about pressure and volume, temperature constant is Boyle's law. Study about V and T, pressure constant is Charles' law. Study about P and T, volume constant is Gay-Lussac's law. Okay, or pressure law. Okay, so Boyle's law, Boyle's, so you have V constant. Kenapa PV constant? P1 V1 equals to P2 V2. Okay, the question normally does not mention about temperature or mention temperature constant. So you will understand this is Boyle's law. Okay, and then we have Charles' law. Charles' law. Charles' law relationship between V and T. V directly proportional to T. T here is absolute temperature. Absolute temperature. So means temperature in Kelvin scale. Okay, Kelvin. Dalam unit Kelvin, bukan degree Celsius. Okay, so from here we have V over T is constant. Thus we get V1 over T1 equals V2 over V2. So ini ialah Charles' law. And then for Gay-Lussac's law, so is P directly proportional to T, means P over T equals constant. Okay, volume constant. So P1 over T1 equals P2 over T2. Same thing, temperature T in Kelvin. Portion of unit is very important. For example, if you want to convert degree Celsius to Kelvin, what should you do? So you just add 273. If you want the reverse process, Kelvin to degree Celsius, you minus 273. Okay, so in this formula must use Kelvin. Okay, maksudnya kena tukar ke Kelvin, tak boleh degree Celsius. Okay, and then very important also for gas law is kinetic theory of gases. Okay, so you must know the assumption. Okay, normally that we use is molecule of gas freely and randomly. Ini you dah belajar lah lower form kan. Okay, and then molecules collide collide with other molecules and with elastic collision. Okay, elastic collision. And then there is bonds between bonds, daya ikatan bond. molecules. Okay, and then another one is temperature is proportional to kinetic, and you explain, okay, certain let's say Boyle's law by using kinetic theory of gases. So you must add in this one. It's like the collision, the bond between molecule, the kinetic energy. So this one we call it kinetic theory of gases. Okay. So this one is all about, okay, just roughly about chapter 4. Okay, secara ringkas. So I hope you still remember all. Okay, now we go to the question. Okay, cuba ingat balik semua Okay, we go to the question. Okay, the objective question first. Okay, those online can say hi. Okay, just write in chat. Okay, number 1, diagram 1 shows some ice cube put into a lemon tea drink. Okay, ada ais dalam ni. Ini masukkan air, what happened? Minuman teh lemon menjadi sejuk. The lemon iced tea drink became cold because what caused the drink to become cold? Okay, as you know that the concept of thermal equilibrium, okay, because there is a heat transfer between ice and the drink, right? Okay, so the lemon iced tea drink became cold because we'll go through the question. Okay, latent heat of vaporization is absorbed by ice. So this one is the process is just melting. Kalau vaporization, this is not melting, this is boiling. So it's wrong. Latent heat of fusion is absorbed by ice. Yeah, correct already. For the melting process, ice will absorb heat from the drink. Thus, it melts. Okay, so when absorb heat from drink, the drink will become cold because drink lost heat. Okay, lost heat for the process of melting. So the drink will become cold. Okay, let's go to the next one. C, heat capacity of fusion. So kita tak ada term ini. Okay, heat capacity of vaporization also we don't have this one. So the answer is B, boy. Okay. If you have questions, just write down in chat. Okay, number 2, diagram 2 shows the length of mercury thread in thermometer when placed in ice and steam respectively. Okay. Panjang benang mercury, maksudnya mercury dalam thermometer tu. Okay, so this is the thermometer. So you can see the red color is the mercury thread. Okay, so what is the value of the temperature theta if the length of mercury thread is 18.2 centimeter? Given the mercury thread for 0 degrees Celsius, now the question want you all to find what happened if suddenly the mercury thread increased to 18.2. Of course, there will be new reading of temperature. So here is theta degrees Celsius. 20 cm is what for 100 degrees Celsius. For 0 degrees Celsius, the length of thread is 5 centimeter. Okay, we use the formula which is theta equals L theta divided by 100 multiply using the one that used in textbook. If some of you, our teacher maybe teach you using this one. L theta minus LO. Okay, L theta minus LO divide by L100 minus LO times 100 degrees Celsius. Actually, the same formula. Okay, if you are familiar with the first one, this one, you can use this one, or you can just use this one. Actually, for L theta, I calculate that one first, because sometimes the question already given the L theta and L100, so just calculate right away. So L theta here equals to 18.2 minus 5. So it's 13.2. It's already given 20 cm. Okay, so I just use this formula. Theta equals 13.2 divided by 29 100 degrees Celsius. Okay. Okay, so we get the answer is 66, which is B. Okay. So kita dapat jawapan ialah 66, B boy. Okay, number 3, diagram 3 shows infrared thermometer used to measure temperature. Which concept explains the working principle? Okay, so this one working principle is thermal equilibrium. So this is one principle actually, principle of thermal equilibrium. Okay, so apply. So you put the infrared thermometer close to your head, forehead. Wait for a while, so the reading will be shown on the screen. Okay. Thermal equilibrium is achieved. Okay, number 4, what is the name given to the amount of energy needed to turn 2 kg of water at 100 degrees Celsius into steam? Water become steam. So ini ialah latent heat. Temperature constant. So concept of latent heat. So this one is water to steam is vaporization. Latent heat of vaporization. So the first one, of course, wrong. Okay, this one is 2 kg, for 2 kg. So 2 kg should be latent heat. If mentioned here 1 kg, then specific. Sorry, ini pun salah. Specific ini and I think the bahasa Melayu and English is already wrong. Specific latent heat. Okay. So kalau to turn 1 kg means D will be the answer. But this one is for 2 kg. So for 2 kg we call it latent heat. Okay. Okay, number 5. Apparatus to investigate gas law. If you have done this experiment, I think you know what law is this. Okay, length of the air trap. Okay, and temperature. Length of trapped air represent volume, and then you measure temperature, so meaning V and T. So for V and T, based on the triangle that we discussed before, D, 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 C, G. Okay, so PVT ialah Charles' law. So this experiment is Charles' law. Okay, which of the following statement is true when heat supply is increased? Okay, so VT, V directly proportional to T. So if the heat supply increase means temperature will increase. So means the volume of the gas increase, or we can say length of trapped air increase. Okay, let's look at here. A, volume of water increase. This one never happened. Volume of air trap decrease, also no. Length of air trap increase, yes. Kinetic energy unchanged, no. Okay, of course they will change because there is a temperature change, right? Temperature increase, kinetic energy increase. Should like that. Okay, so the answer, the best one is C. Length of air trap increases. Okay. Number 6, heating curve. So heating curve will show change in temperature and change in phase. Okay, ada perubahan temperature dan perubahan state of matter, keadaan ataupun physical state of the substance. Okay, which of following statement is true? We go through one by one. A, at stage P, kinetic energy of molecule of solid substance is unchanged. P di sini actually ya. P kat sini. Okay. So P here, solid state. No change in phase. So you can see temperature change to here. Maybe here is negative 20, something like that. Change to 0. Other temperature change. Okay. There is change in temperature. So there's no change in phase. We call it specific heat capacity or heat capacity. So of course there will change in kinetic energy. So untuk first punya ini salah. At stage Q, solid substance melting to liquid. So you can see when reach here, no change in temperature. Okay, so Q, it will cause the solid to melt to liquid. So Q ialah melting. Maksudnya betul untuk second. Stage R, solid substance change to steam. R, here is liquid change to steam. Wrong. Ini ialah liquid state. Okay, no change in phase, there is change in temperature. So ini ialah heat capacity. Okay, untuk Q, latent heat of fusion. Okay, saya ulang balik ya. P, heat capacity. Q, latent heat of fusion. R, heat capacity again. Okay. And then S, balik sini S. Okay. So this one is latent heat of vaporization. Okay. Ini wrong. S, latent heat of vaporization, correct. Okay, absorb. So we have 2 and 4. Answer ialah C. Okay, number 7. Diagram 6 shows 250 grams of water at temperature 40 being poured into glass filled with ice at 0 degrees Celsius. What is the mass of ice that melts? Okay, so there is this one is calculation. So this one is a latent heat of fusion, latent heat of fusion. And then there is change in temperature also, meaning there's also heat capacity. Okay. So we want to look at ice. Initially, ice is 0 degrees Celsius. Once water poured into ice, ice will receive heat energy and then change to water 0 degrees Celsius. This one is melting process. We call it latent heat of fusion. So MLF. And then temperature increase, water increase to 40 degrees Celsius. Means there are two types of heat here. Latent heat to melt the ice and latent heat heat capacity to increase temperature. So ada dua jenis, Q1 and Q2. Thus, we want to calculate M, mass of ice melt, dapat di sini. So kita guna konsep heat released by water. Oh ya, saya nampak ini ada mistake sikit. Okay, we do it again. Sorry. Because the temperature of water is 40. So this is a mixture. Okay, let's look. Alright, again. Okay, ice 0 degrees Celsius, 40 degrees Celsius. Okay, so water plus ice mixed. Okay, so the final temperature. Okay, heat released by water equals to heat absorbed by ice. Okay, so we have heat by water, heat absorbed by ice. Okay, so mc theta equals to final temperature. Okay, is ml fusion. So we have 250 over 1000. C is for water, 4200. Okay, let's say 40 degrees Celsius minus 0 because finally it become cold. So M finds the latent heat of fusion 3.36 then power 5. Okay, so you need to can we get the answer? Okay, you try and calculate. You should get the answer for number 7, 0.125 kilogram. Okay, number 8, closed steel gas cylinder. Gas pressure and the temperature of gas inside closed steel cylinder are 200 kilopascal and 27 degrees Celsius. What is the gas pressure when heated to temperature 40? Okay, let's list out what given in these questions. So you have pressure P1, T1. Okay. So what is gas pressure? Means P2, T2. Okay. So this question, relationship between P and T, so is Gay-Lussac's law. So you have P1 or T1 equals T2 over T2. Okay. So P1 is 200 kilopascal. T1 40. So I need to T1 is 27. 27 need to add 273. Okay, convert to Kelvin equals P2. We want to find temperature 40 plus 273. Okay, you solve for this one, you will get your answer in kilopascal because P1 here is kilopascal. Okay, so you try and see, you will get the pressure P2. P2 equals to 208.7 kilopascal. Okay, means temperature increase, pressure increase, so your answer should be larger than 200. Okay. Okay, number 9, a scientist carried out an experiment on gas law. Table 1 and graph shows data of experiment obtained. We have temperature in degrees Celsius, convert to Kelvin, and volume. Volume and temperature is what? Is Charles' law. Okay, so which statement is correct regarding the experiment? Volume of the gas directly proportional to Celsius unit temperature. This is wrong, as we know for Charles' law, T we call it absolute temperature. Okay, volume of the gas directly proportional to absolute temperature. This one is correct. Value of volume of the gas is 0 at 0 degrees Celsius. No, it should be 0 at 0 Kelvin. Okay, V0 at 0 Kelvin, we call it absolute zero temperature. Ini lain. Maksudnya 0 Kelvin bukan 0 degree Celsius. V0 bila 0 Kelvin. So answer ialah C. Okay, number 10. Two identical containers were filled with two different types of liquid. Okay, at room temperature and heated at same rate. Okay, diagram 9.1 shows reading of thermometers for liquid P and 9.2 is liquid Q. This one 50 degrees Celsius, this one is 100 degrees Celsius. So this one we discuss about type of material and so when we talk about type of material means specific capacity. Okay, so specific heat capacity and temperature, the relationship is inversely proportional. Okay, see, yeah. So which of following statement can be used to explain observation in 9.1 and 9.2 as we look at here? Okay, let's say same initial temperature post liquid. So after some times, this one 50, this one 100, meaning Q experienced larger change in temperature. Larger change in temperature means smaller specific heat capacity. Or we can say Q heats up faster than P. Okay, Q lebih cepat panas banding P. Okay, maksudnya specific heat capacity Q is smaller than P. Okay, we look at the answer. Okay, A. Okay, so you have the already this one. Okay, we go back to here. Mass of P is smaller. Sudah mention identical, so ini salah. Identical maksudnya same mass. Jadi, density of P is smaller than Q. Okay. Smaller, ini tak betul. Okay, specific heat capacity of P is higher. Dan Q, okay, tadi dah tunjukkan sebab ini smaller change in temperature, so P is higher. Okay, so C is correct. For density, we cannot see anything. There's no information to compare density. Only we have its mass only. Okay, specific heat capacity higher than Q. The specific P is smaller, so of course this one is wrong. So answer ialah C. Okay, if you have any question, just write in chat. Tulis dalam chat. If you don't agree with the answer, also you can write in chat. Okay. Okay, that one done already, paper 1. Now we go to paper 2, section A. Diagram 1.1 shows a steamer as instrument to steam food. Okay, ini ialah steamer, electric steamer. Okay, A1, state the meaning of latent heat of vaporization. Okay, ingat kita ada dua kan, latent heat and specific. Okay. Okay. Kalau mention latent heat means for m kg of mass. Kalau specific is 1 kg of mass. Okay. So for latent heat of vaporization is amount of heat required to change. Ini vaporization, maksudnya ialah liquid to gas or steam. Change liquid to gas. No mention about mass. Okay, so we keep for any mass. For any mass. So definition for latent heat of vaporization. If the question is latent heat of fusion, sama juga, cuma di sini ialah solid change to liquid. Okay, itu saja beza. Okay, if they want the specific latent heat, you kena mention 1 kg of liquid. Kena mention 1 kg kalau specific. Okay, 1 mark. Okay, part 2. By using the concept of latent heat, explain how steaming food can cook food faster compared to boiling method. 3 markah. So 3 points. Okay, so the first point, okay, we discuss about boiling dulu. At boiling point, water absorbs latent heat of vaporization, which is larger, to change to steam. Vaporization. Change to steam. Okay. Okay, the steam, what happened to the steam next? When the steam, okay, reach the cover of the steamer. It will condense to water. Okay, steam, steam bila kena cover atas, cover sini. Okay, boiling tadi dia produce steam. So steam when touch the cover, it will experience condensation process. Okay, become water. Okay, so the process of condensation will release out larger latent heat of vaporization. Okay, and release larger amount of heat, latent heat of vaporization. Okay. The amount of heat release is much larger compared to heat supplied during boiling. Okay, so the boiling process also supply heat, okay, to cook food. But the steaming process, due to the condensation will release out latent heat of vaporization. So the amount of latent heat of vaporization released is larger than the heat capacity that's supplied during boiling. That's why steaming will cook food faster than boiling. Okay, jadi you kena explain process of condensation, then you compare heat energy release. Okay, jadi ada 3 point di sini 3 point. Mesti ada 3 point. Okay, boleh baca, then you can use your own words. Okay, if you understand, you can use your own words. Maybe my explanation here is quite long. You can make it shorter. Ini release release yang dibebaskan. Okay, bagian B, 800 gram of water at temperature of 30 is filled in the steamer pot for steaming food. The power of steamer is 1000 watt. The food is steamed for 50 minutes. Calculate total amount of heat supplied for the steaming process. Okay, heat supplied by heater, PT. Okay, heat absorbed to change the temperature. Okay, ada change in temperature. Okay, until boiling boiling process, boiling di mana steaming food Jadi kita ambil the final temperature is 0 sorry, is 100 degrees Celsius because during boiling, the condensation occur. So we can take 100 as a final temperature. So you have heat capacity and there is change in liquid to steam. So kita ada MLV, okay, latent heat of vaporization. So PT, P equals to, given is, bahagian B1 dia suruh calculate. Okay, ini belum saya. Just calculate heat supply saja. So kita nak cari gunakan formula ni. Okay, heat supplied by heater equal to T. So you have 1000 watt multiply 15 minutes convert to, okay, so you're going to convert second sebab heat energy kita guna unit joule. Joule ialah SI unit, time in second. So you get 9 times 10 power 5 joule. Okay, gantian betul, unit jawapan betul. Okay, now calculate mass of water change to steam during period of heating. So kita ada PT equals M sub M. Okay. PT tadi sudah calculate 9.25 equals mass of water is 0.8 kilogram. 800 gram you convert to kilogram. C 4200. Change in temperature, boiling point, 100 minus 30 plus M LV. LV ada di sini, 2.26 10 power 6. Okay, so you solve for this one, you can find M. Cari M. Okay, 0.294 kilogram. Okay, you must try, use calculator to calculate. I want to make it faster, so I just write down the answer here. You can calculate by using this method. 2 marks. Okay, state one assumption. Kalau tajuk heat ni hanya ada satu saja assumption. There's only one assumption. Assume no heat is lost to surrounding. Means all the heat that supply is absorbed. Okay, heat supplied by water is absorbed by food. Okay, no heat is lost to surrounding. Okay, number 2, diagram 2 shows a steam iron. Power of steam iron is 1 kilowatt. 1 kilowatt means 1000 watt. Okay, so dia ada water point and also steam outlet. Okay, first question, what is meant by power of steam iron 1 kilowatt? Means the steam iron will consume of energy in 1 second. Okay, kalau 1000 kilowatt maksudnya kalau you guna iron tu 1 second you sudah guna 1000 joule. You boleh imagine lah kalau you guna 10 second sudah 10,000 joule. Okay, macam tu. Okay, so this is the power of the steam iron. Bagaimana I calculate amount of heat required in units of joule heat. Okay, so kita akan guna formula ni. E equals to PT ataupun Q formula ya. Q lah sebabnya heat energy, so biasa guna Q. Okay, kita guna Q. Okay. Q equals to PT 1000 multiply 3 hours 3 hours convert to second. Okay, ni kena convert second times 60 times 60. Okay, so you will get the answer is 1.08. Okay, so ini guna 3 hours dia dapat ini. Okay, some modification need to be made to the structure of steam iron so that the ironing process is more efficient. Okay, so how would you do it based on this aspect? First is size of water pot. Water pot, we put water and then water will change to steam. So we need to use bigger size or larger size. Okay, size of water pot is bigger. Reason, okay, banyak jawapan berterima. Can store more water, can use for longer period. Okay, the water is enough for supply in longer period. Okay, larger amount can got or can supply steam. Okay, maksudnya large amount of water can be stored atau can supply steam for longer period. Maksudnya you masuk sekali you boleh guna lama lah sebab air banyak. Okay, number of holes at the steam outlet. Okay, so number of holes must be more lah. More number of holes. Why? More number of holes can release more steam one at a time. Okay, maksudnya lebih efisien lah. Jangan tulis efisien. Kalau you tulis ni more efficient, tak ada apa. Kenapa tak ada markah? Sebab sudah mention ke atas. Sudah mention di sini cannot repeat. Okay, so ini tak ada markah walaupun betul sebab atas dah sebut. So jangan tulis what is given dalam soalan. Ni tak boleh. Okay, the size of holes at the steam outlet. Okay, steam outlet, the size is smaller. Okay, kita nak spray out at high speed. Okay, we want to spray out the steam at high speed. So to produce okay, okay, kita nak produce smaller spray of steam at high speed. Okay, semburan halus. Okay, kita nak hasilkan semburan halus and high speed. So dia lebih baiklah, lebih efficient to iron your clothes. Okay, soalan section B. Diagram 9.1 shows an arrangement of apparatus to determine specific heat capacity of water. What is meant by specific heat capacity of liquid? Nampak tak? Ada perkataan specific. So, heat required, required to increase the temperature of 1 kg liquid by 1 degree Celsius. Okay, nampak tak? 1 kg by 1 degree Celsius. Okay, so ini ialah specific heat capacity. Okay, amount of heat required or needed to increase the temperature of 1 kg liquid by 1 degree Celsius. Okay, kalau ada soalan boleh tanya sambil ni saya boleh jawab. Okay, kalau ada. Okay, part 2. Explain how specific heat capacity of water it is determined using arrangement of apparatus. Ini proses dia kena explain juga Weigh, measure, SM, okay. And initial temperature. So awal theta I. Turn on the switch. Okay, record final temperature after 5 minutes as theta F. Theta F final. Okay, number 3. Calculate specific heat capacity as C equals to PT divided by M theta F minus theta I. Okay. So ini ialah soalan ialah explain how is determined. Okay, 2 markah. It's not 2 lah, I think. It's this part, right? I think the marks is already wrong. Mentioned here. It's not 2 marks, sorry. This is 4 marks. This is knowledge question 4 marks. Okay. So kena tunjukkan dengan jelas semua ni. Ada lagi satu step sepatutnya, number 4. Number 3 ni. Ini dah number 4. Sebab ini tadi saya nampak ialah 2 markah. So it's 4 marks, sorry. 3 markah means you calculate change in temperature. Okay, theta. Okay, so theta ialah theta F minus theta I. So C di sini you dapat ialah N theta. Sebab kita nak bagi 4 markah untuk bagian ni. Okay, so first weigh mass of water as M and record initial temperature theta I. Turn on the switch, record final temperature after 5 minutes as theta F. Okay, calculate change in temperature theta. Calculate specific heat capacity as C equals to PT divided by M theta. Ya. Jadi 4 markah sepatutnya 4 point kat sini. Ya. Okay, bahagian B, immersion heater of power 100 watt to heats up 250 gram water, temperature 30. Water heated for 5 minutes until temperature 59. Calculate total heat supplied by immersion heater. Okay, Q equals to PT means 100 multiply five times 60. Okay, you get the answer and power. Okay, sebab dia nak heat supply sahaja, so Q equals to PT. Ambil power heater multiply time. Time dia 5 minutes. So 5 minutes convert to second. So, dapat Q dalam unit joule. Calculate specific heat capacity of water. So gunakan formula C equals to PT divided by M theta 2 divided theta 1. Theta is initial temperature. So you have 3 times 10 power 4 divided by 0.25, the 250 gram convert to kilogram. Change in temperature, 59 minus 30. Okay, so you click for C, you will get 41380 kg negative 1 degrees negative 1. Okay, so the value of the theory value is 4200. So maksudnya hampirlah jawapan kita dapat. Okay, 2 markah. Part 3, state one assumption, sama saja. No heat is lost to surrounding. Okay, yang online tak ada soalan ke? Yang online dengan saya? Okay, bahagian C shows a cooking pot with lid. Periuk masakan. Ini tutup dia, lid. Then there's a steam hole, ada satu lubang kat sini. Okay, soalan. Table 1.2 shows KLMN. Okay, 4 cooking pot design with different specification. Okay, you nampak sini properties, material of body part, specific heat capacity, inner part of cooking pot, and lid of pot. Okay, properties ni kita nampak di bawah. Okay, kita tengok yang pertama. Material of body part is either stainless steel or ceramic. So which one we should use? Okay, so read through all question first. Tengok lagi bawah. You are required to determine the most suitable cooking food faster. Cook food faster, and food stays hot, and the food is safe to be consumed. Okay, kalau stays hot maksudnya it will keep the heat for longer period. Specific heat capacity should be larger, not smaller. Okay, kalau smaller dia cepat sejuk. Okay, cooking panas cepat. Okay, dia cepat masak juga. Okay, the food stays hot and the food is to be consumed. Okay, tengok properties dia. Material or body part. Okay, stainless steel or ceramic. So I will choose ceramic because the property is to store food hot longer period. Okay, jadi I don't want this stainless steel, I will choose ceramic. So normally we remove 2 out of 4. Okay, and then the specific heat capacity of handle. Handle you need to hold it during cooking, so cannot be heats up faster, it should be heats up slower. So specific heat capacity should be high. We don't want the low one. Low one akan cepat panas, nanti you tak boleh pegang dia semasa memasak. Okay, inner part of cooking pot. Adakah dia coated with a synthetic or natural coating? Okay, ini untuk consume, safe to consume, so we don't want the synthetic. Okay, we use the natural non-stick coating. And then lid of pot, adakah without hole or with hole? Okay. Okay, so kita ambil yang ada hole. During cooking, when you close it, okay, kenapa we want to release some of the pressure. Kalau tak nanti dia lompat atau explode pula. Okay ya. Jadi kena ada steam hole semasa tu. Ini bukan pressure cooker. Ini adalah kena ada steam hole. Ini without, sorry. Okay, so we choose which one is suitable. You can see clearly N, all the required characteristic. Okay, N has it. So now we explain based on N. Okay, untuk 10 marks ini ya, 10 marks. Expect already given dalam tadi. So kita just write in. Okay, kita tulis jawapan dalam table form. Okay, expect yang pertama. Material. Tulis semua aspek dulu. Material of body pot, of body of pot. And then the second one is specific heat capacity. Of handle, pemegang. And then the inner pot, coating of inner pot. Number 4, cover of pot. Okay, okay, now kita dah tulis aspect, maksudnya tak ada yang tertinggal. Okay, material of the body pot just now, stainless steel or ceramic. So we choose ceramic. Specific heat capacity of handle should be high. Inner coating of inner pot is natural coating. Cover of pot with steam hole. Okay, nampak tu. And then give reason. Okay, ceramic. The food will be cooked faster and keep stays hot lah. Okay, specific heat capacity of handle. Okay. Heat not. Okay. Can be whole during cooking. Coating of inner pot. Okay, sebab kita tak nak dia kalau sintetik, takut nanti dia come out, jadi cause the food to spoil. Will cause prevent food poisoning. Ataupun dia cakap tak apa, okey lah tu. Okay, cover of pot with steam hole. to release pressure in the pot. Okay, ataupun to reduce high pressure ataupun to reduce high pressure at high temperature. Okay, sebab high temperature, high pressure. So kalau you cover without steam hole, it will cause maybe you can cause explosions because high pressure. Okay, so release some of the pressure during cooking. So and is chosen because all this. Okay, okay, so you will get 10 marks for this one. Okay, so this is for section B. Okay, you try to draw a table like this and write down the answer on your own. Okay, part C. Okay. Diagram 1.1 shows graph of heating for two types of liquid, P and Q respectively. So, you nampak ni ialah P, yang bawah ni ialah Q. Okay. Based on the graph, name the changing phase process that occur. Okay. Jadi nampak ini dekat bahagian sini. Okay. Ini ialah gas, P, dia explain di sini heating curve for liquid. So means liquid change to steam. Okay. Okay, based on diagram, compare shape of the graph, way in which the mass of liquid changes, mass of liquid P and liquid Q that change after heating. Name the concept involved in the change of mass of liquid. 5 marks. This is mass against time, showing how mass of the liquid change. Okay, so you can see from here for this one, the above one, okay, for liquid P. Okay, so if we look at certain time, let's say for 500 seconds, for P is 480, for Q is 380. Okay, so means change to steamer for Q occur faster, okay, than liquid P. Okay, kita look at the shape to compare. Ini kena tulis 5 point. So for part A2 number 1 section C, try to write here sebab tak ada space di situ. One A2. Okay, 4 marks. 4 marks. Sorry, 5. Compare dia punya shape of the graph. Okay, for both liquid, bentuk sama. Same. Okay, second point. Time taken for liquid P to change to gas is longer. To change to steam is longer than Q. Okay, third point. P absorb latent heat. To change to then Q. Okay, next. Mass of liquid P changes more after heating as compared with. Okay, saya dapat ada 4 markah. Okay, mark yang kelima, you kena state konsep. Liquid P and Q undergo process to change to. Okay, so the process is boiling. 5 markah. Ini 5 markah untuk soalan ni. 5 marks. Soalan B. The heating of liquid P and Q as shown is using identical 50 watt immersion heater. Calculate specific latent heat of vaporization liquid P for time interval E. Graf balik untuk bahagian ni bahagian ni saja. Okay, you nampak tak? Untuk 500 to 2710. So, dia punya mass difference is 480 minus 260. So, get is 220. Okay. For Q is 380 to 200. Ini 380 to 200 is high. Okay, so change in mass, mass that change to liquid. Okay, now we want to calculate specific latent heat of vaporization liquid P for time interval E. So this one just the process of boiling, boiling. So constant temperature, no change in temperature. So Q equals to MLV. Okay. Dan kes ni, so just gantikan T 50 watt. Time of heating ialah berapa second. Kira lah untuk A tu A tadi. Sini. Berapa second. 710 minus 500 is 210 seconds. And if you want to find mass, sorry. Mass already calculated tadi. 0.220 gram. So you kena convert to kilogram, maksudnya 0.22 LV. Okay, so cari LV, latent heat, specific latent heat of vaporization. So you will get the answer. Try to calculate 4.77 10 power 4 unit joule kg -1. Okay. Untuk part 2, calculate specific latent heat of vaporization of liquid Q. Okay, tadi ini untuk P, sekarang untuk Q. So sama juga PTMLV. Same hour, identical. Time taken also same. 380 minus tadi 2 280 minus 180. So convert to 10.18 LV. So you cari LV. 50 times 210 divide by 0.18. So you will get 5.83 10 power 4 joule kg -1. So from here you can see the specific latent heat of vaporization for Q is larger than P. Okay, so ini ialah pengiraan dia. Okay, part C. Diagram shows a pressure cooker that can cook food faster. Okay, so nampak komponen, handle of pot, body pot, lid of pot, cover dia, and base of pot. Okay. Soalan, using the knowledge about heat transfer, suggest a pressure cooker design that can cook food faster and safe to be used. In your explanation, emphasize on material based features at the of the pot. Okay, 10 markah. Okay, jadi soalan ni saya akan buat dalam table form untuk section C. So, identify all the aspects. Saya akan masukkan aspek dalam table untuk section C. First, material of handle. Okay, second aspect, jangan tulis body saja, pressure cooker. Siapa? Di pressure cooker. Okay, untuk body dia kita boleh letak dua aspek. Okay, let's say yang first you nak first material. Second, you boleh letak dia punya thickness. Okay, thickness of pressure cooker. Body dia boleh lah kalau letak macam ni pun. Okay, and then kita boleh letak Okay, material of base of pressure cooker. Okay, and lid of pressure cooker. 1, 2, 3, 4, 5. Okay, so I have listed here 5 properties. Okay, so material of handle, kalau material topik heat ni always refer to specific heat capacity. Okay, ataupun dia punya strength. Dua benda tu. Okay, jadi kalau sebut material saja, you boleh refer kepada C atau material apa, you boleh letak. Okay, so material of handle mestilah high specific heat capacity. Ataupun you letak di depan pun boleh. Okay, specific heat capacity of handle pun boleh. Okay, ini high specific heat capacity. Material or body. Body mestilah low specific heat capacity. Okay, thickness of the pressure cooker, body dia mesti thicker, mesti thick, tebal. Material or base. Okay, material or base is high density. Ataupun you nak letak low specific heat capacity, tapi itu sudah cover tadi body ya. Kita ambil yang lain. Okay, high density ya, base part. Lid. Okay, dia punya cover dia kena ada steam lock. Mesti ada. Okay. Okay, boleh explain satu-satu. Okay, material of material of handle, high specific. So the handle not hot. Cold, hot tak panas. Okay, material of body. Okay. Faster. And become hot. Faster pun boleh. Okay, kalau you tulis cook food faster, adakah diberikan dalam soalan? Tengok balik. Cook food faster sudah diberikan. Nampak? Safe to be used dah diberikan. Ini you tak boleh ulang loh explanation di sini ya. Nampak? Okay. So dia cepat panas. Okay. Cook food faster, dia cepat panas. So jangan tulis cook food faster, heats up faster or become hot faster. Okay, dia tak boleh tulis cook food faster kat sini ya. Reject reject. Okay. Okay, thickness to withstand high pressure. Sebab during cooking the pressure is very high. To withstand high, dia mudah pecah. Okay, material of base high density means not easily topple down atau distable. Okay, lid of pressure cooker ada steam lock to prevent steam from release out. But kalau steam release out, no use lah sebab pressure cooker high pressure inside the steam always release out latent heat of vaporization during cooking. Okay, because the steam will hit the lid and change the steam, change the water through condensation. So the latent heat of vaporization all trapped in. So high amount of heat inside the pressure cooker will cook food faster. Okay. So saya ada 5 di sini, so I have enough to get 10 marks. Okay, if you have more idea, you can just add in. Okay. So that's all done for topic heat. Okay. So I take quite longer time, nearly 2 hours. Okay. Nearly 2 hours. So if you have question, you can ask, you can write in chat. Ada soalan tak? Ini panjang memang panjang. Kalau you tak mampu untuk lihat one whole this video, you can just watch. Okay, maybe first 30 minutes and then you can continue later. Okay, I understand you cannot focus for longer period. You have any question regarding this one? Siapa yang online, who still online with me, yang ada soalan? Okay, if no question, I end my session now. Okay, thank you for joining me. Bye.